Welcome back to another Hungry Turtle Code video, and in today's video we will be building this. So it's a nice parallaxy, scrolly type of thing. We have this zoomy, and then this is more of a traditional parallax scrolling thing. We've got this nice progress bar, and it is completely responsive to scroll. We can even use the scroll bar on the side, and it will still function perfectly. So that's what we're going to build. Let's jump into it. As always, the code for this is linked on GitHub in the description below. And if you want to see a written version of this tutorial, the link for that is also in the description. Okay, so story time. This was originally supposed to be a really short, sort of 10-minute tutorial that I would just throw up. And the reason that came about is I saw Bear Grylls' website, which looks something like this, and go away. And as you scroll, you kind of zoom into the mountains and you get this nice parallax effect, and then it fades into this next thing, and we just have this sort of parallax site. It's really quite nice. I was quite impressed by it. So I decided I wanted to recreate it, and I would do a quick 10-minute tutorial showing how I did that. But then, as I started building it, I started realizing that I could actually build quite a nice abstraction and make it into a library. So I did that. And then I had the idea, why don't I make a series about how I took the idea, wrote some hacky code that would implement it, realize I could make it into a library, abstract everything, generalize it into a nice library, and then deploy it onto NPM. So that's what this series is now. We're going to write the initial hacky code just to get it working, and then we'll make it into a library that people can use, and we'll use best practices like testing and Git hooks and linting and all that sort of thing, and then I'll explain how to actually deploy that onto NPM using Travis continuous integration so that it's all done automatically on Git tags, using all kinds of best practices. And this is kind of like a professional workflow where it goes from idea and concept all the way through to the implementation and deployment of an open source library. So I thought that'd be pretty cool. So that is what this series is about. So let's jump into it and write some code. So here we are at the terminal, and I'll show you what I currently have in this project. So I have an index.html, an index.js, and a main CSS. So we'll open up Vim and we'll take a look at what we've got. So the index.html, as you can see, it's very simple. It's just a basic scaffold. We're linking to the CSS. We're linking to the JavaScript. Nothing complex there. And in the CSS, we again have nothing complicated. We've just removed the margin and padding from everything. And then we're setting the body height to 5,000 pixels. This is kind of arbitrary, but I just want to have something there initially so that we have some scroll, so that we can actually hook into scroll events. But that isn't, but that's kind of a random value that I picked just so that we have something. And then the important bit, the JavaScript. So right now we don't have anything. So the first thing we're going to want to do is just set up an event listener to listen for scrolling. So we will do that now. We'll just say document.add event listener. We'll listen to the scroll event and we will give it a callback. Then here I'll just say console log, we are scrolling. Save that, and then I'll open up another terminal and I'll run live server. So we'll notice here we're still in the same directory, and we'll hit live server and it will open us up into the browser where we can go to the console, we can scroll, and we can see we are scrolling. So our event listener is working. So I'll quickly just explain Live Server for those of you who don't know. So Live Server is just a tool you can install globally via npm using npm install-g live-server. And then when you run it in a directory like this, it will just serve that directory through a web server into the browser. So as you saw, it opened us up at localhost port 34,000 whatever, and in there we can see whatever's in the directory that we're in. So it's serving that HTML, and that HTML is pulling in the JavaScript and the CSS and all that sort of stuff. And it just allows for a really nice workflow when we're just dealing with static HTML and JavaScript. So it doesn't do any fancy bundling or like Webpack rollup, that kind of stuff. We'll get into that sort of stuff later, but for now, we We don't need it. We just need a web server to serve our HTML. And this is exactly how we're doing it. So back into here. So now that we know everything's working, we've got scrolling working, we want to add in the HTML elements that we're going to interact with as we scroll. So the site's kind of split up into 3 sections. So if we go take a look at it again, we've got this section here, which is the Hunger Turtle mountain zoom thing that is kind of like the Bear Grylls site as we scroll down. This is the second section where we have the text splitting and the turtle zooming in. And then the third section is this more traditional parallax scrolly type of thing. So I'll add in the HTML for this first section first. So just open up the HTML here, and I'm just going to copy paste in the HTML we need, and then we'll talk about it. So there we go. We have an app, which is just a div that's wrapping everything that will be inside our app. So we have a div with fixed section and first page. So we want it to be a fixed section because as we scroll, we're not actually scrolling. The whole thing stays in place, and we're just manipulating the view and the scale of things to show the parallax kind of zoomy effect. So we want that to be fixed. So that's why I've added that, and we'll add the CSS for all these classes in a bit. First page, just to let us know that. And then we have the heading, Hunger Turtle code, and then we've got background, middle ground, and foreground. And then inside of each of these, we have a block. And the reason we've done this is because of the way we're manipulating things with CSS. So as we zoom, we're actually just scrolling and scaling up each of these elements. So we're scaling the title, as you can see, and then each of these 3 sections are also scaling, but they're scaling by different amounts, which is what gives us that parallax effect. But then in CSS, as we scale, there's a point from which we're scaling from, an anchor point that we're scaling from. But because each of these elements is actually in a different location, the anchor point will be different. But as we're scrolling in and zooming and scaling these elements, we want them all to scale from the same place so that it kind of looks uniform. If they're scaling off in weird ways, it's not going to look quite right. So we wrap each element in a div and then make that div the full size of the screen, and then scale that div, and everything inside it will scale along with it. But because we're scaling that outer div, the anchor points of each of them are the same. So everything will scale uniformly and look nice. So with that said, we'll save that and open up the CSS. And again, I will just paste in that CSS and we'll explain what's actually going on. So we have the app, which we've just positioned as fixed at top 0, left 0, made it 100% width, 100% height. That makes sense. And then the fixed section, we're just saying position fixed. We're positioning it at 0, all top, bottom, left, and right. Giving it a background color and a z-index of 2. And that's just so that we can see it above other things that will be fixed position potentially. Then we have our background, middle ground, and foreground. So this time these are absolutely positioned, and we've positioned them at 0 on top left, bottom, and right. So that's how we're making it full screen. So then we have background block, middle ground block, and foreground block. So ultimately, if we take a look here, these are at angles, but they started off their lives as just square divs. And we've just skewed them at different angles and then positioned them accordingly so that we kind of get this pseudo mountainy looking thing. So if we take a look at the CSS, we can see background block, we've given it a color, positioned it, and then we've positioned it based on like -10 of the view height, so it's like scaled down or moved down a little. It's 100% width, given it a height, and then transformed it by skewing the Y 2 degrees. And then we look at the middle ground block, again, same kind of thing, just positioned it somewhere, given it a width and a height. Then we've skewed the Y plus 40 degrees this time. And the foreground block again, we've colored it, positioned it wherever we need it, skewed it -20 degrees. And that's how we're getting these positioned at different angles. And then we've just like moved them off left, right, up and down or whatever to get them exactly where we want them. But those positioned are absolute relative to its container, which is the foreground, middle ground, and background containers. And then we've just got the heading, position that where we need, and then just given the first page H1 a title. So I don't want to spend too long on that CSS because I'm more focused on the JavaScript in this tutorial. But if you do have any questions about the CSS, because I kind of rushed through that, firstly, experiment with it in the browser, load up the code and dig around, experiment, change things. But if you're still kind of stuck, you can open up an issue on the GitHub repo for this, where links in the description, and I'll try and help you out. But I'm far from a CSS expert. It's not really my expertise, but I will do my best to help you out. Okay, JavaScript. So focusing on this first section, we're going to want to make all of these move. And I said we're going to scale them up. So the first thing we're going to need to do is grab hold of these different elements in JavaScript land. We'll do it up here. We'll say const foreground equals document.query selector. And we'll query for foreground. And then we'll copy that. So now we've grabbed hold of the things we want to manipulate. We want to grab hold of our current scroll position inside our scroll event listener, and then manipulate these elements based on that scroll position. Okay, so first off, I'll say the y offset equals window.page y offset. Remove that console log. So now we have the y offset. So I'll just console log this out, y offset, and go back into the browser and we'll see what we have. So we can see here our HTML and CSS is looking how we expected it to. And if we just open up the console, so then as we scroll, we can see a pixel offset for how far we've scrolled down the page. And as we move the scroll bar down, we can see this value getting larger. And if we start moving the scroll bar back upwards, the value continues to get smaller. Now we want to use that offset to do something to animate our HTML. So we'll just remove that console log, and I'll just initially create a constant, and I'll call it mountain scale end, and I'll just give that a value of 500 pixels. So this is the point at which we want the animation for the mountain scaling to have finished. And then with that, we can then calculate how far into the animation we are. Like as a percentage, we're 80% through the animation, or we're 54% through the animation, or whatever. So now we want to check if y offset is less than this mountain scale ending value. And if it is, we want to actually do the animation. So initially we will calculate the percentage that we are through the animation, and we'll do that by dividing y off, the offset, by the mountain scale end value. So at this point, if we're at 0, 0 divided by 500 is 0. If we're at 500, then 500 divided by 500 is 1, so we're 100% complete, and everything in between will just work out. So using this percentage, we want to scale each of these elements by a certain amount, but we want to scale each differently. So the way we scale something using JavaScript is to grab hold of the style attribute of the DOM element. So we could say, for example, foreground.style, and we want to use the transform because we're going to scale something. Transform equals, and at this point we'll use a template literal, which allows us to add JavaScript variables into a string. So we want to have it as a scale, and then we want to add in some JavaScript here, and we want it to be at least a scale of 1 because that's where it starts off at. And then what I'll do is add on the amount that we want to finish at, so say 0.4, and then multiply that by the percentage. So when we're at 0%, we get 0.4 times 0, which is just 0, and then we get 1 plus 0, so the scale is just left at 1. And when we're all the way at 100%, and this percentage value is 1, then we're getting 0.4 times 1, which is 0.4, plus 1 is 1.4, and that's how much we're scaling for. So by doing it this way, and multiplying a constant value by the percentage, we will scale from 1 to that value. It's exactly what we want. So now we'll just repeat the same for middle ground, and instead of 0.4, we'll use 0.1 this time, and we'll do the same for the background, And instead of 0.1, we'll use 0.04. And these are kind of arbitrary values that I've tinkered around with and they kind of look good to me, but you can have a play with those and see what other effects you can come up with. And we'll do the same for title. And this time we'll scale that up to 0.35. And then we'll save that. So now, just a recap of what we've done. We're checking if the offset is less than the end of the animation. And then if it is, we're calculating the percentage through the animation that we're currently at based on that offset. And then scaling up each of the elements based on that percentage multiplied by a constant. So if we come into the browser and take a look at what that gives us, we can scroll and we can see we're kind of zooming in. But once we get past 500 pixels, nothing happens because that if statement doesn't trigger and we're not doing anything extra. So now we can scroll all the way down to the bottom of the page, nothing happens. Scroll bar can go crazy, nothing happens. But then as soon as we hit the 500 pixels, we'll start scaling down again. So as long as we're in that 500 pixel range, it'll do something, but after that, it does nothing. So that's a start. So now we've got that sort of scaling stuff. The next thing we want to do is if we jump into the original example, as we scroll down, when we hit 500 pixels, the first section starts to fade out. We can see the mountains just fade out into this solid color. So I'll create another constant and I'll call it transition end. And I'll say it ends at 800 pixels. So it's 300 pixels later. So the transition takes 300 pixels. And then have another if statement, just else if y off is less than transition end. And then here, we're going to want to fade out the first section. So we'll need to actually grab hold of the first section. So we'll say first page equals document dot query selector dot first page, just so that we have that. And then we want to do the same percentage trick and calculate how far as a percentage we're into the transition. So that will be, this is a slightly trickier calculation. So instead of being y off divided by mountain scale, y off now needs to subtract mountain scale because we're going from 500 to 800. So when we're at 500 pixels of scroll, we're at the 0 pixels into the transition. So we want to take that 500 away. And then we also want to take 500 away from transition end. So this will be y off minus mount scale end divided by transition end minus mount scale end. So that's kind of a weird thing that we're having to do, and ideally we wouldn't have to have all these kind of calculations. We'll build a library in the next part that does all of this for us. But for now, we're doing it hacky and just getting it done. So now we just want to change the opacity of this section based on the percentage through the transition. So we can say first page dot style dot opacity equals, again, we'll give it a template literal, and in here we'll say 1 minus percentage. So when we're 0% through the animation, the opacity is still 1. When we're 100% through the animation, the opacity will be 0, and we're just scaling linearly between the two. So now if we save that, come back into the browser, into the one we're working on, we can scroll down and then we start to fade out. But we'll notice here, we're not 100% faded out. So if we scroll really fast, we barely fade out because we got past the transition before we were able to do everything in it. Because this scroll event is only called periodically. So if we're scrolling fast, we get less scroll events called per distance of scrolling. So if we scroll so fast that we skip past this transition before we can do all of the animation gets caught in this weird inconsistent state. So what we're going to need to do is reset that after we're past the transition and reset the opacity to 0. So that even if we skip past it really quickly, it'll still be at 0 when we're past it, so that we can't see everything. So it kind of still looks like it worked. And we can go fast, nothing, and if we go fast backwards, we haven't reset back to 1 here either. we're still in this sort of in-between opacity zone. So to fix this issue, we will add in this first section here, we'll say first page dot style dot opacity equals 1. So now if we save that and come into the browser, and if we scroll fast down, we still have this problem because we need to reset it to 0 when we're past it, and we'll do that when we create the next section. But now if we scroll really quickly upwards, we still end up with an opacity of 1 now, because even though we've got past the transition and didn't manage to do it quickly enough because we scrolled too quickly, we're still telling the browser if we do get to this area and we're past the transition, set the opacity to 1 here. So there we go. So now we will create the second section. So when we scroll past, we'll see the title and we can then animate that. So we'll jump into that now. So we first need to add in the HTML for that section. So I'll just copy paste it in here. So we can see here we've got fixed section again. This time second page, another heading, but we've split out the heading into 3 words with a span around each word. That's because we want to animate each individually. And then we have this image, which is the Hungry Turtle code, Mascot, and that will be what's scaling in after the transition of the words. So now that we've got that, we'll just quickly add in some more CSS. So this is the CSS that we've got. So we've got second page, we set the background, second page H1, we're setting the color. We've got a scale of 1.35 on this title. And the reason for that is we're matching it to the scale of the previous section's header. And we're starting that previous section header at scale 1, but as we scroll, we're zooming in. And the constant that we set for that zoom was 0.35. So that heading will result in, at the end of the animation, it will be scaled to 1.35. So if we want this heading to match, we've got to set the scale of it to 1.35. And moving on, we're setting the spans to inline block, and then the turtle mascot, we're just positioning it and setting the scale to 0 because it'll start at nothing and then we're scaling it up. So back into our JavaScript, we're going to want to grab hold of each part of the title. So we'll say title parts equals document.query selector all this time because we want to grab all of the things that match this. And this will be second page H1 span. There we go. So now we want to set another constant, which will be the end of the word splitting section. So we'll say word split end equals, we'll say 2300. And we'll add on to this if statement. We'll just give ourselves a bit more space so we can see as well. And we'll add another else if y off is less than word split end. So then here I'll grab hold of the current offset within this section. So that'll be offset equals y off minus, and remember y off is the global offset that we're totally scrolled down the page, and we'll take away transition end. So transition end is the end of the previous section. So if we take away the end of the previous section from the global, we get the current offset into this section. And then we'll say title part. So this is where we'll start animating stuff. So the 0th, which will be the word hungry, dot style dot transform equals, and we will translate 3D 0, and then we'll put something in the next part, and then this will also be 0. And then here is where we'll put some JavaScript. So we want to offset it minus the scroll. So we're scrolling downwards, and we want the hungry to move upwards. So we'll make that a minus, and then offset, and we want to minus offset pixels. So as we scroll down 10 pixels, the word hungry will be translated up 10 pixels. And that's how we get this sort of animation upwards. And then we want to take the word code, which is not the first, it's the second. So if we just re-jog our memory, as we scroll here, hungry moves up, code moves down, and then after some delay, turtle starts to move to the left. So hungry is the 0th word, and code is the second, So then we'll translate code. Instead of negative offset, we'll translate it by positive offset. So as we scroll down 10 pixels, code will be translated down 10 pixels too. And then we'll also take the first element, and instead of having any JavaScript in here, we'll just make sure that it's at 0, 0, 0. So it's reset to 0 in all cases. And then we'll check if offset is greater than 300 pixels. So this is just a random number that I've picked that kind of look good. Then we'll animate this turtle. So we're waiting 300 pixels of scroll. So as we see here, we're scrolling and this is moving, but turtle stays still. And that's 300 pixels, and then once 300 pixels is done, then turtle starts to move. So all we do is check if offset is greater than 300 pixels, and if it is, title parts1.style.transform equals translate 3D, and we'll translate it by negative offset minus 300. Because of course offset is the offset into the whole section, so if we take away 300, then we're into the offset of just where the turtle starts to move. Give that pixels 0, 0. Now save that. We'll jump into the browser and see what we've got. And refresh. Okay, so we're not seeing the first section, so we must be Z index maybe? Z index 1. Okay, so we need to do second page Z index is 1. Told you I wasn't very good at CSS. So we'll say second page Z index and set that to 1. Now if we refresh, so as we scroll we're zooming in, then we fade out, then our Hungarian code move, then our turtle moves. And there we go, so that's that. We'll come back into the code and we want to do the scaling turtle now. So we'll grab hold of that, we'll call it turtle mascot equals document.query selector turtle mascot. And then we'll come back here and we'll have another if statement, and if offset is greater than 500 this time, then we want to start scaling up the turtle. So we want to calculate the percentage that we're through the scale of this turtle. So we'll say percentage equals, and this is just like we had before. So this is offset minus 500 because we're starting at 500. And then we divide that by word split end minus transition end minus 500. So I know this is kind of a hairy calculation and difficult to wrap your mind around potentially, but we're just taking the end of the word split, which is the end of this whole section, taking away the end of the previous section, which gives us the length of the current section, and then taking away 500 because we're only starting at 500 here. That gives us the length of the turtle scaling, and then we're using that to divide through to figure out the percentage. I hope you understand that. And then we'll say mascot image.style.transform equals scale 1.2 times percentage. We're doing 1.2 just to scale it up slightly bigger than what it is by default. And we'll take a look in the browser at what that does. So as we scroll down, we see nothing happening. Okay. Uncaught reference mascot image is not defined. We called this turtle mascot. Call this mascot image. Come back down. Back to the browser. And there we go. So we're scaling up to there. Perfect. That's exactly what we want. Good. So with that done, let's create the third section. So again, we want to add in the HTML. Just add it here, and I will paste it below so we can see it there. So we have a third page. Notice this isn't a fixed section anymore because we actually want this to scroll. And we have a progress line, the title, H2, some images, and just 2 images here. And then this bottom section, which just provides some sort of padding at the bottom. And we will add in the CSS at the bottom. And we'll take a look at the CSS quickly. So we have the third page, which we've translated down 100% of the view height. And the reason we've done that is because we don't want it to be in view. We want it to be the fixed section of the first section, then that fades out, then the fixed section of the second section, and then the third section needs to be below it. But because the second section is fixed, then the third section will be behind it. But we don't want it to be behind because we're not fading out the second section, we're scrolling it. So instead, we'll translate that third section down by 100% of the view height. So it's just below the view. So as we start to scroll, then it'll come into view. Then we set the background, the padding, then the title. We're just making it a flex title to center it easily. And then the images, position relative, margin. We're positioning this relative because each image inside is positioned absolute, and absolute will go to the previous position. Again, I'm not explaining CSS. And then we're just setting the position of each image, setting the color of the title, giving the bottom section a height, just as I said, to pad it down. And then the progress line, positioned absolute, 2 pixels, it's red, it's 100% height, shifting it in left a little. So we're translating this up 100% so that it's above the third section when it starts, and as we scroll, we'll then translate that down. And z index of 0, just so that when it is translated up 100%, we don't see it in front of the second section, instead it will be behind. So that is the CSS. Jump back into the more interesting stuff to me, the JavaScript. And there's a few elements we're going to want to grab hold of up here. So this time I'll just paste them in. So we grabbed hold of the whole app, the images by query selector all, and the progress line. So we're going to want another constant here, which will be the end of the whole page. Const end of page equals 3450. Again, randomly chosen. And then kind of know the drill now. Else if y off is less than end of page, then we want to do stuff. And we'll grab hold of the offset, which is y off minus the end of the previous section, which is word split end. We'll also get hold of duration, which is the end of the page minus the end of the previous section. And now we want to actually scroll. And the thing is here, we have the second section fixed position. So as we scroll, it doesn't move. So how do we then get it to move when we hit the start of the next section? And we're kind of going to do some trickery. So it's not actually scrolling in the native scroll manner. Instead, we're taking the whole app container and translating it upwards at the exact same pace as we're scrolling. So that has the effect of looking exactly like we're scrolling, and that the scroll wheel or the scroll bar at the side is controlling the scroll. But in fact, we're just translating the whole app upwards. So app.style.transform equals translate 3D 0 and then minus offset pixels and 0. So we save that and go into the browser, take a look at what we've got. We can scroll down, we get all of the scaling as we thought. Then as we hit that point, we start to do what looks like scrolling. But if we take a look at the Elements tab, we can see here that the whole app is actually being translated upwards by -668, and then as we scroll, that's changing. So it's giving the illusion of a scroll. It's just a translation upwards at the exact same pace that we're scrolling. So it looks like scrolling. Good! Okay, so now we want to do this sort of fancy parallaxy thing and do the progress bar. So we'll come back and we'll say images 0.style.transform equals translate 3D 0 minus offset. This time we'll like multiply it by some constant, so we'll say minus 0.1. Plucked out of the air, 0. And we'll do the same for the second image, but we'll have a different constant, say 0.25, so that they're moving at different paces. If we come back into the browser, take a look at what that looks like, we can see here that these two are moving at different paces, giving that nice parallax effect. The final thing to do before we fix some bugs is to implement the scroll bar. So the scroll trigger we'll say is progress trigger. So this will be the point at which the progress bar starts to scroll downwards. So that'll be duration, which we created up here, times 0.2. So basically 20% into the duration, that's when we'll start the progress bar. And then we can do if offset is greater than progress trigger, then we can do some progress stuff. And this is kind of like what we've done before. We want to get the duration of the whole progress bar section. So that is progress duration equals duration minus progress trigger. And we want to get the offset into the progress section. So progress offset equals offset minus progress trigger. And then progress equals progress offset divided by progress duration times by 100. So that we're timesing it by 100 here because we're going to actually deal with a percentage in the translate. So we're just multiplying it by 100 so that we can actually deal in full percentages, not a decimal. Progress line.style.transform equals translate 3D, and we're going to translate by minus 100 minus progress percent and 0. So this is why we multiplied this by 100, so that then because we're using percentage, we can take that percentage away from 100, that progress, and end up with the percentage here. And that will be how much we translate that progress line downwards. And remember, we're taking this away from 100 because we actually started the progress bar at minus 100 translated upwards. So when the progress is 0, we want it to stay at that minus 100 point, right? So when progress is 0, that would be 100 minus 0%, so that would still be translated up minus 100. And then as we come down to complete the animation, progress will be 100. 100 minus 100 is 0%, so that's back down at the bottom, translated 0. So we'll take a look at what we have. So we scroll, we can see all of this stuff happening, and then we can see here. So as we start to scroll through into this section, we haven't got the progress bar started yet because we only triggered it 20% through. Then as we scroll a bit further, this starts to trigger, and then it's racing down past until eventually we reach the bottom, and as we do, it reaches the bottom here. Perfect. And now we need to fix all the bugs. So we've got all the kind of major interactions happening, but if we scroll around the page fast, we'll see everything is kind of breaking. So if we scroll quickly through stuff, we get this, and we get this where we've got turtles. It is just a mess. There is so much going on that's not right when we scroll quickly. And the reason for this is that we need resets for each section. So before we reach a section, the section should be in a certain state. And then as we hit the section, we're animating through that state, and we're changing the state as it's animating. And then when we reach the end of the section, there's a state that it should be to finish. And then we scroll past. But if we scroll really quickly, the animation doesn't get time to complete because the scroll events don't fire quick enough. So we don't end up in the state we should be at the end. So when we scroll back into that section, it's all wrong. And we might get things that are showing up that shouldn't be showing up because things aren't reset correctly. And then as we scroll back up, we have the same problem. If we scroll back up through a section, we don't end up finishing the animation, the backwards animation, and things aren't in the correct state. So this is kind of a long-winded way of saying we need to have a reset of a state before we reach a section, then animate in the section, and then reset the finished state after we're out of the section. So we'll need to do that for each of our sections. So the first thing we can do here is just an else here and say progress line.style.transform equals translate 3D 0 minus 100% and 0. So that's just making sure that if we're not inside this progress trigger, we're just making sure that we're at minus 100%. So that's the first thing. So we'll just start at the top and we'll work our way down. So we have this transition end, and then that goes into the next section, which is the word split. So we need to make sure before we reach the word split that each of these word parts is at 0 translation, because when we're scrolling back upwards, we're doing all of this. If we don't manage to get through this correctly, this is in an inconsistent state. So in here, we want to title parts 0.style.transform equals translate 3D 0, 0, 0. We'll duplicate that for each part like so. So now we've reset each of these parts to 0. So that's one bug. So another bug is that if we move too fast through here, the first section hasn't been reset to 0 opacity, and potentially we move too quickly that the scale of each of the elements in the first section didn't get to up to its full scale. So when we come back, we'll have a jump as it resets again. So we want to reset the scale to the full amount that it needs to be, and we also want to reset the opacity to 0. So we will do that in the word split end. So we want to do it at the end of the transition, so that as we're coming back, we're resetting it before the transition starts, which is before we'll see any of it. So we'll just do it up here. We'll say title.style.transform equals scale 1.35. So foreground.style.transform equals scale 1.4. So this is all coming from the constants that we used in the initial section. We'll say middleground.style.transform equals scale 1.1, and background.style.transform equals scale 1.04, and then first page.style.opacity equals 0, and save. So now if we come in and we zoom past that section, we see it's gone because we've reset the opacity, and if we come back, it reappears. And the transition is nice, and there's no jumpy size changes to the scale of anything. The opacity works. But now we can still see here, tiny, but we can still see the little turtle mascot. So we need to reset that to 0 scale when we're before it, and then as we move past it, we also want to reset it to 1.2, which was the total scale that we used for that, so that when we transition back into it, there isn't a jump. I'll see if I can create it. If we scroll really fast, and now if we scroll back up, the turtle won't be big enough and there'll be a jump in its scale, hopefully. So there it's there, and as we scroll, we saw that little jump up as it reset. So we need to fix that top and bottom. So we'll go to the final section here, and we'll just say mascot image.style.transform equals scale 1.2. Make that a string. And then we want to take that same thing and reset it. Probably here. We'll set it here. Somewhere. Reset that to 0. So now if we take a look at what we've got, we can scroll through and everything works. And if we scroll back, everything's nice. If we go quickly, this time when we scroll back, there isn't a jump here as this turtle comes into view, and there's no jumps here. So we're all good. So there we go. We have something working. There are still a few reset bugs in this code. So if you want to try and fix those on your own, you can go for it and see if you can figure those out. Just tinker with it by moving through, scrolling really quickly and seeing where the bugs are, see what happens, and see if you can figure out how to reset them. But that is basically how you implement this. But you might have realized that the code is not very nice. It's very hacky. It's kind of confusing to figure out all these percentages all the time and calculate the relative offsets and do the resetting of things, and there's just a massive mixing of concerns where we're resetting section 2 and section 1's code, and it's just not very nice. It kind of feels gross. But the point of this video was just to illustrate how to do it. But in the next video, we'll take all of this and we'll convert it into a library that does all of the hard work for us. It does all the resetting, and it allows us to calculate the offsets and all that automatically, and the resetting of things before and after a section will be made much, much easier, and there'll be separation of concerns. And I'll talk you through how I do it and what I'm thinking, and I think it's a good illustration when you have code like this in this video where it's just hacky and we're doing a lot of repetitive stuff. Usually you can abstract that away and have a nice library that will do it for you. And that's exactly the thought process I went through when I wrote this code initially, and I've now taken that and written the library, and you're going to see my whole thought process through from this video all the way through to deploying a library to NPM. So I hope you enjoyed this video. I hope you got something out of it. I hope the code wasn't too disgusting for you, but we're learning, and that's the main thing. So if you enjoyed this video, hit the like button. If you do like what I'm doing in general, hit the subscribe button, hit the bell notification to get notified when I upload new videos. And if you really, really like what I'm doing, you should check out my Patreon. The link is on the video somewhere, and it'll be in the description as well. But until the next video, stay hungry and keep coding.